Good morning once again, guys. I trust our weekend was fine and our last week went well. Yeah, so welcome to class this morning. And today we'll be going for another hour of learning Rust. And we'll continue from where we stopped in the previous class. That was last week. And just to give a brief, we talked about conditional statements last week. We touched variables already. We spoke about integer types, data types generally, but the simple data types. And then from the simple data types, I went into talking about variables, then conditional statements, right? Then we touched panics also, right, which we looked at, and why you use panic in your code. And after talking about panic, I also mentioned loops, right? That was where we jumped to. So we spoke about the while loop, the for loop, and the loop syntax. So I touched on the loop syntax, talking about having loops and loop labels, right? So those were like everything we touched at the high level. Then we spoke more about them. We dive deep into like talking about them and understanding them. Show you guys examples of the loops that I'm talking about in space. So which is the for loop, touch the for loop. Then we did a bit about the loop also, which was not here. I think I pointed that out from here, talking about the flows, right? We'll talk about control flows, and then we'll talk about the loop. We will mention the kind of loops we have, and I showed you guys example how to run an infinite loop, how to break out of the loop if you are using the Rust loop syntax, and how you can read past the loop value that was returned, the value returned from the loop into a variable, and then now you can use that variable elsewhere within your program, right? So how we can have labels for loops. We didn't really touch this, but I just mentioned it, right? How you can have labels for loop, where you can have something like this, and then, like I said, this you are just indicating that this should have lifetime by indicating this sign, and it should exist for the lifetime of the program rather. And then you are running your loop here, but within this loop, there's another loop, right? So you can reference this first loop here just by making reference to the label that you added to this loop here. So it's possible to have multiple loops, and then you can make reference to them within each other. So it's more like you having a for loop in a for loop. You have a loop in a loop, whereby you have nested loops, right? So in this way now, it's easy to manage those loops because you have a label for each of them. So Rust allows you to be able to do something like that, and then it just makes sense, right? So that is one beautiful thing about the loop syntax in Rust. And we gave examples of while loops also, right? We showed how they work, we showed the syntax, and I spoke about all of them having almost similar syntax, whereby for the loops generally, starting from the if statement, we don't use parentheses in Rust, right? So we just declare the keyword, whether the for loop or the if statement, then we define the condition that we want, right, to execute as true. And then we define the scope, right? And the scope for that condition. So the body of the function that should run, that should be executed if that condition is true. So those are things we spoke about. Then I showed examples, and just to give you a few of the examples, let me go back to this. So I'll show you guys what we did, the playground. So we did some of those things, and basically that was where we stopped, right? So we stopped at the loops last week, and then I said I just touched on the other loop syntax without diving deep into it, and then I said last week we're going to continue from there, just to give a bit of preview of what we did last week. So I think everybody is caught up now, if I'm not mistaken, as to what we did last week. This is taking a bit to load. Why? My network is good enough. Okay, so that's basically what we did, right? So today we are going to continue from there, right? We are going to continue from where we stopped. And by the time we move on in this class, we are going to make references to all of these things also. I think that is important to mention because we don't expect to just touch these things once and just touch it like that and leave. Now, the reasons why we have these books and the reason why we have the books and the examples, the exercises, is so that we can always come back to them, right? So in your journey as a Rust developer, as a developer generally, whether for Rust or not for Rust, is that you always make reference to the documentation, no matter how expert you are. At times you need to come back to the basics to just see one thing and then pick from it. So definitely we'll be making reference to all of these things. But as we move on, we're almost done with two. And as we move on from that chapter, then we can begin to solidify our knowledge in Rust and begin to do much more than we could do before. But still, we will come back to it and then still look for, like, still understand the conditions, the rules that govern the Rust programming language. So by the time, anytime we make reference to any of the topics we've covered before, just understand that that's what we are trying to do. We are trying to solidify our knowledge on the previous things we've learned, right? So that is going to happen. So don't be surprised if that keeps happening, because it's definitely going to happen. What is happening with Rust Playground? Why are you not working? Oh yes, so it's back. Okay, so now that was what we did. So what the things we did last week? We covered the for loop. We talked about the while loop. We talked about for loop. We talked about, we gave examples, right? We gave examples of the loop syntax and the loop labels. Even though we didn't give an example of loop labels, I showed you guys on the call. And then aside from that, we gave different instances of panics, how it works, and an example of panic. And we actually thought of logic to implement our panic, to implement panic in our Rust programs, right? So, and then you guys provided the simple examples as to what we can have in how we can implement panic in our code. You guys gave an example of conditions where things could go wrong and why you want to panic for those things. And then I mentioned and spoke about macro, but we didn't talk about it. I just said we're going to talk about it eventually, and that they are just functions, but you can look at them as special functions, right? Macros are special functions in your code. So all of these things are important. They are necessary to just know. And I know that we spoke about all of this, but I'm just going back to this so that you guys can have a refresher, right, of what we did last week. So that is that. So now that we are all caught up, let's move on to today's activity. Now, from where we stopped last week, we talked about loops, right? We stopped at loop. Now, let's look at overflow and underflow. Now, overflow and underflow is something we've already talked about, kind of, when we spoke about the integer data type, but we didn't like go deep into talking about it or expressly talk about it as a topic. But now let's look at what this means, right? What is overflow? Now, just as the name implies, it means you are going beyond, overflowing means you are going beyond a particular thing, right? So it's not like you're extending the range that exists. And that range now simply means, remember when we talked about the integer data type having a range, right? Having a maximum range. So let's say the range of an 8-bit integer is basically 2 raised to the power 8 minus 1, right? So that means in that case now, if you go beyond that and set 256 or 300 to a U8 integer data type, unsigned integer data type, you get an error. In that case, remember we spoke about the overflow error, and I showed you guys from the example that there's an overflow error in that situation. Now, that is basically what we mean by that, right? So when you talk about overflow now, you are basically talking about that phenomenon or that condition that happens or the results that you get when you exceed the particular range of a memory size, right? That's basically what we refer to as overflow. So in this case now, let's look at this. The factorial of a number grows quite fast. Yes, but let's look at this. When the result of an arithmetic operation is bigger than the maximum value for a given integer type, we are talking about an integer overflow, right? So now let's look at this. What I mean by this, we already spoke about that. So let me see if I can pick an example we used earlier. Yeah, so let me pick this. Yes, U8. Okay, let me just define a new one. So in this case, if I define a new variable, say we define a variable to be a U8 equal to 300. Now, clearly, 300 is greater than the maximum value that a U8 integer type can take, right? So now, if we try to run this program, we expect it to give us an error, right? Because we've gone beyond the range. Remember that we said that Rust is a statically typed programming language, and Rust compiler does the job of keeping your memory very, very, very safe, and does the job of allocating memory as you define using your data type. So if I already specify a U8 data type here, Rust has already provisioned an 8-bit memory size for me. So trying to put in a variable, a value that is greater, that is higher than that value, Something is wrong with my network today. I don't understand. Trying to set a value that is greater, right, than the expected memory maximum size will give you an error. So in this case now, I'm trying to run this. I don't know. My network is just messing up today. I don't quite understand. Strange. Hey, can you guys hear me, please? Just to be sure that the call is not having issues. Hello? Okay. Okay. So what is wrong with this playground? It should be working fine. My network is fine. Okay, I think this might just be a good time to use the local to stuff to work with Rust locally instead of just trying to use the online playground because it's really misbehaving. Took so long to load. Now it's not even working. Uh, Something's wrong. Okay, so but basically what we are talking about is that we have this working. Um, we have if you run this line of code now, you are going to get an overflow error, right? Of course, this is not giving me what I want. It's not loading well. Let me try to restart this. Let me restart this. Okay. So let me restart this. Still loading. Sorry, my network is just messing up. So please bear with me. I don't know what's happening this morning. This is quite unusual. Playground is so slow. Is it going through maintenance? Wow. Mm, I, hmm. Okay. It's just taking time. But then, like I said, if you have if you have a code like U8 and you assign 300 as a value to it, it's definitely going to give you an overflow error because the maximum value, like we said the last time, is that it cannot, right? It cannot and it should not take in a value. So having a U8 integer data type like this, let's say we set A, we got A to be this, and then we set 300 to it. This is going to throw an error, obviously, because remember that the U8 integer data type only takes in 2 raised to the power 8, like this, minus 1, which is equivalent to 256 minus 1, which is equal to 5 max. So the maximum value it can take, or the range, if you had put it in the right word, since we already learned about range last week, is to say 0 to 255 equal to, right? So now you can see that U8 is equal to 0 range of just from 0 to 255. And then we know that U16 in its own calculation to will give us 0 to 65535. 5, right? So in this case now you can't add a value greater than 65,535, but you should use 16 integer data type, unsigned integer data type. So now that's what an overflow basically means, right? This thing is loaded, still slow. Okay, so that's what we refer to as an integer data overflow, right? So now integer overflows are an issue because they violate the contract for arithmetic operations. So it basically means that you are violating the rules, right? Like I said, we've talked about this before, but I just want to, speak more about it because it's something you encounter a lot. And then when you encounter those kind of errors, you feel like, oh, okay, I already understand what it is. So it's good to be very familiar with it so that it doesn't keep you too much when you are writing your cross code. So the result of an arithmetic operation between two integers, exactly. So there are times when you might not really violate the rule, like assigning something like this. You might not really violate this kind of thing. But say you have two variables, say you have let A and B, and you have SAB also is a U8 data type, right? That takes in, let's say this is 200, but mistakenly you assign this to 64, right? They are both are valid, right? And let's say you have results like this, right? And you say result is also a U8 type, and then you are assigning A plus B. You know that by mistake, you can't remember the value of this and this. So it's very easy to fall into an overflow error because you are not keeping track of all of this, right? All the time. So in this case now, this is valid. Yes, this is valid. Yes, but this you throw an error because at the end of the day, you have the value of 264, which is greater than the maximum value. So this will give you an overflow. So what is happening? Sorry, just okay. Is there a question? My screen is not showing. Oh, exactly. That's the thing. My network is really acting up. Okay, yeah, it's showing for you, Bashir. Right? It's not showing for Judith. That's the thing. So my network is really off this morning. I don't know why, but it's just I don't know. You just bear with me for this. I'm sure it's just a temporary thing because the network should be fast, very very fast. So please, Judith, if you can't see my screen, right, you can just try to join the call again. Okay, it's showing now. All right, nice. Okay, so going back to what we've been talking about, let me see if this will work so I can show you guys what I've been writing since. So in this case, hopefully this works. Please work. Please work. Please work. This has been slow. Jeez. Wow, this is not going to work. Okay. I hope this doesn't delay us this morning as much as. So this is basically the thing. So in this case now, this is an overflow error, right? So this is what we are talking about when we talk about overflow errors. So it might not happen directly at um in initialization of the variables, but it might happen within execution of those of maybe extra code or further code along the line, along your code, right? Or your code logic. So that's basically what this is talking about. And that's what this is telling us. So it's telling us that when you have something like this, right, it might happen because of an arithmetic operation, might happen because of maybe just basically because of arithmetic, since it's an integer um error basically. So exactly. So the result of an arithmetic operation between two integers of a given type should be another type integer of the same type, but the mathematically correct result doesn't fit into that integer type. So it might happen because of that, like I explained in this case now, right? This is one reason why it might happen in this case. So if the result is smaller than the minimum value for a given integer type, refer to the event as an integer underflow, right? So now let's look at an underflow error. How does that work? So in this case now, this is an overflow, right? An underflow is just the opposite of the overflow. Let's say we have this. Let's consider this now. So an underflow is just an opposite of the overflow. Remember that a U8 integer type has a minimum value of 0, right? Now in this case now, let's say we have, let's see, a U8 integer type, and the C basically is in this case 20. 20 is still within the U8 memory size, so it's valid. So let's define another variable, call it D, and say U8. U8 in this case now, let's say is 25. 25 is valid, very valid. So now let's say we want to make a result 2, right? You know, this is valid now. This line of code is valid. This line of code is also valid. It's a valid ROS code. But in this case, we can make a mistake during operation, during an arithmetic operation, by getting a negative value. And a negative value, remember, is less than what is expected for an unsigned integer type. So if I make this an unsigned integer type, it should not go below 0. But if I do this minus D, obviously I'm going to get what? Minus 5. And this already becomes an what? An underflow error because it is below the minimum value for this data type, the U8 data type. Please, is this clear to you guys? Is there any question? Is there something that is not clear? I know I've not been able to show you guys practically because of the playground that is not working or my network that is messing up. But is this clear? The explanation from this place, is it very clear? Is there any question from there? Okay, so I assume there are no questions then. Okay, so let's proceed. So now from that, you can see the kind of errors that can occur. And remember, we catch something like this, or we caught something like this during this last code we did, right? Remember, we caught an error like this when we did a panic of to check that end must not be less than start, because it can cause an underflow error. And then we panicked and we returned the panic message that it must be greater than the start value. So that's basically an example of what we are referring to in this case, right? So that this can trigger an underflow error, and there are most times that other errors that can be triggered are overflow errors. So now let's conclude on that. So now there's nothing to know. There's no automatic promotion for when you talk about overflows. Now, what possible approach would be to automatically promote the results to a bigger integer type? So let's say, for instance, if we have something like this, let's say we have the addition of this is 264, right? And this maximum is 255. You could have thought about it that Ross could have just changed it to maybe a U16 integer type to accommodate for it. But what we need to understand is that there's no automatic promotion at all. No automatic promotion. Now, because it's not going to increase the value for you, right? So you can look at what this said. But as we discussed before, Rust is quite picky about type conversions. Automatic integer promotion is not Rust solution to an integer overflow problem. Rust, as we talked about, is very strict. No, we talked about it from the beginning of the class. It's not going to change it for you. It expects you to follow the principles, the rules that is defined for you, and they expect you to write your code in the proper way, right? You have defined unit 8, stick to unit 8. That's what it's trying to tell you. So Rust will force you to be disciplined in your code, right? So now, what are the alternatives you can use? Now, alternatives you can use is you can reject the operation. So, okay, look at it now. Since you ruled out automatic promotion, since you ruled it out, what can we do when an integer overflow occurs? Now, there are two things. You can reject the operation, or you can come up with a sensible result that fits into the expected integer type. That is what Rust wants you to do. This second one is what Rust wants you to do. It wants you to look at your code and think well about it. You don't just write code, because your code is powerful. It can do things, it can spoil things, it can make things. So Ross expects you to do that. Okay, whenever you are writing your code, you have this mind, you have this thoughts, you have this focus that whatever I'm writing should work the way I expect it to work. Code is not magic, right? It's just logic. It's not magic, it is logic. So because it is logical, Ross expects you to follow a logical approach to writing it. Rust, you can't write a code and be like, oh, I don't even know why this is working. Obviously, you know why it is working, because it will force you to understand what is happening and why it is working. So it's one of the most beautiful things about Rust language. So once you begin to understand the language more, you fall in love with the way it enforces some things on you, right? So now, how do you reject the operation? We already talked about the panic last week, right? So panic is one way you can reject the overflow operation. For instance, look at this code I showed you guys here, where we talked about the speed. Remember that last week you guys gave me an example of what could go wrong with this logic here. And you guys said that one thing that might go wrong is that if the end is greater than the start, is less than the start, it will cause an error. And then we add a panic here to specify that if it is truly less than the start value, you should return this value, this panic message. End value must be greater than start value, because we are trying to prevent an underflow error here. So one way to prevent underflow and overflow errors is to reject the operation. And rejecting the operation is what we've done here. We rejected the operation, then we are using panic. Okay, so that's the first thing. Also, you can come up with a sensible result. Like I said, this is the one Rust expects you to actually use. Right. So this is it. So when the result of an arithmetic operation is bigger than the maximum value for a given integer type, you can choose to wrap around. Now, remember me mentioning something about wrap last week, right? I mentioned wrapping. I don't know if you remember that, but even if you don't, we're still going to talk about it. Whereby we can wrap integers. We are still going to see that syntax whereby we'll talk about wrap or wrap into a lot. Now, if you think about all the possible values for a given integer type, such as a cycle, wrapping around means that So what do you mean by that? Let's say an example. If you do a wrapping addition between 1 and 255, right, which is the maximum for a U8, the result is 0. Now, if you are working with signed integers, the principle applies. Adding 1 to 127, right? With wrapping, we give you minus 128. Now, what do you mean by this? Let's look at this. Let me show you something. Since the playground is not working, I'm sorry, we need to do a bit of coding without running for now. I don't understand why it's not working, but then please just bear with me. So what we are talking about in wrapping is this. Let's look at what wrapping means. In this case, what it means by wrapping additions, right? Wrapping additions or wrapping around. Let me just use that. Wrapping around. Now, simply means that when you reach the maximum value in this case now as a U8 equal to 250, right? Now in this case, this will give me 300, right? The value of this to give me 300. So in this case, I'm going to get result as a U8 we got to what 300. But if I wrap this using wrap around, now look at this using wrap around, right? Instead of this to fail and give me an overflow error, the value is going to be what 5. Why? Because it's going to be the value is going to be 300, right? Which is 250. 250 plus, it's not 300, right? It's supposed to be 255. 250 plus 5, which is what? 255. Okay, no, this is not what I'm trying to explain. Let's make this 252, right? So 300 plus 252, in this case, is going to be what? 257. 257 is already much more than 255. So the answer is going to give me 1, actually, in this case. I don't know if you get, because the value is more than the maximum value that a U8 can hold. So it just start from the beginning. So look at what is explained here too. If you look at this now, it said the addition between 1 and 255, the result is 0, right? Because it has exceeded the value. So in this case now, this is also 257. 257 will give us 1. Why is it going to give us 1? Because the moment it got to 255, right, which is the maximum it can take for U8, it's going to just break 255 out of the result and start the next count from 0. So if it's 256, let's say this is 4, the value here will be 0. Now if this was 6, right, and this is 258, let's assume, what would the value of this thing be if you use wrap around? It's going to be 2, right? So that's what they're talking about. Now this, you don't really need this, but it's good to see because there are times you will see this on certain code basis and be like, what is happening here, right? Just know that is a wrapping addition. What you get now? If you think of all the possible values now, when you do that, when you choose to use wrapping addition, when the result is bigger than the maximum value, you can choose to wrap around. That's the meaning. So it's just good to have an understanding of this, right? So when you see something like this, you have a higher value, but it returns to a lower value. You understand that it is what? It is a wrap addition around that is happening automatically. So that's how that works. Please, any question regarding this before I proceed? For the wrap around, is it clear enough? Okay, so I just assume it's clear, right? Should I assume it's clear? All right, thank you. Please. Okay, so now that we've done this, right, the next thing to do is the next thing we check is the overflow checks, right? Now you can set overflow checks. I don't know if I mentioned this before, but overflow checks is basically what you set at profile setting. Now, profile setting is a configuration you set when you like. Let me show you guys. I think it should be on the playground. You can set your profile settings. I think I should be able to configure that. It's not here. It's not here. But then if you were using an offline version of this, right, we will be able to set our configuration for my profile. Meaning that if I check my profile, we'll still see that when we start using offline um when we start working offline, right? Using the actual, if you have installed Rust and then we do all of those installations and then we start using VS Code or use, you know, what they call the name, Rust Rover, JetBrains, and you will see these things happen. So let me just show you an example. Let me open my JetBrains IDE sharply. I think that just makes sense. Now let me just open that now so that we can use that to even work there. So let me create a new project. It's just a very simple Rust project. Okay. Shush. Let's keep that for now. So let's just continue. No, to avoid me installing all of those things from scratch. So now we have this, right? Overflow checks basically just know that there are things we do in profile, right? Profile, when we start working with those things, I will explain what profile means. I'll still talk about them in detail. Profile, when you can have your like start cargo build or cargo run. And when you cargo run, in the dev version, that's when you use a cargo release, all of those things. We'll talk about them eventually, right? We'll talk about them. So, but for the profile settings, we'll make mention of the profile settings, right? We'll talk about them when we start working with the Rust program locally. Do you get now? So now let's look at the next thing, which is saturating arithmetic. Now I'll just fly by this. It's not going to be like much discussion here. So first thing you need to understand is overflow check is a blunt tool, right? Which we talked about from this place, which, like I said, when you define your overflow checks, you are simply saying that, okay, should overflow be checked in Rust or not? Right? You can specify it, and that's what I was talking about in this overflow check. Now, Rust lets you, the developer, choose which approach to use when an integer overflow occurs. The behavior is controlled by overflow checks. Now, when you set it to true, Rust will panic at runtime when an integer operation overflows. If overflow check is set to Rust, Rust will wrap around when an integer overflow occurs. Do you get what I'm? Do you get now? So Rust will actually panic based on your configuration. Like you said, there are two approaches that Rust will go for. It will either reject the operation or come up with a sensible result that fits into the expected integer type. So if you set your overflow check in your profile to true, it's going to reject the operation when an overflow or underflow occurs. But if you set your overflow check to false, meaning that Rust should not panic when an overflow occurs, it's going to do what? It's going to wrap around. You get now? It's going to wrap around. Now, you may be wondering what is a profile settings? A profile setting is just a set of configuration options that can be used to customize the way your Rust code is compiled, right? Rust Cargo provides two built-in profiles, the dev and the release. The dev profile is used every time you run cargo build, cargo run, or cargo test. It is aimed at local development. Now, do you get what I was saying the other time? So it's just for local development, and we are still going to do that when we start local development. But for the sake of not starting that, and which I feel like we might start it today, because if this doesn't work in the next few minutes to explain what I want to explain, I might have to just jump into local development. I didn't plan to do today, but then I was already planning to do that for the next class. So I might just do it today if this doesn't work out. So that's the next thing we need to do. So when we get to that point, we will explain the profile, right? And we'll talk about it. So let's talk about saturating arithmetic. So saturating arithmetic, this is still not working. So saturating arithmetic in this case, like you say, overflow checks is a blunt tool, right? It's a global settings that affect the whole program. Now, it often happens that you want to undo integer overflow differently, depending on the context. Sometimes wrapping is the right choice. Other times, panicking is preferable. Do you get? So there are times, like I said, when you check some code bases, you will see wrapping being used. And you'll be wondering, how is 255 and 1 equal to 0? It doesn't make sense, but that is what it means. Because we are using what? We are using the wrap around method. Do you get now? we are using the wraparound method. Yes. So these are advanced Rust level developer styles. So, but when you see it, you shouldn't be too surprised. You've seen it now in action. You see what it does. So it's just a wrapping method. So now let's look at it in action. If I have this thing, it's not working. What is happening? Oh my god. Okay. Sorry, but I just need to install Rust. I can't get to keep explaining this class without doing anything. I was planning that I was going to explain it eventually, right? And I think now is the best time. So I don't have Rust installed currently. So it's just the best time to show you guys how it's being done, how it's being installed from scratch, right? And that is what we're going to do. Because I can't be able to show you guys these examples. I want to show you how it works. I want to give you other examples that I have in my head, but I can't write it out. I can't show you guys. So please just give me like a few minutes to just while we're on this call, so that when you want to set up also, and if you're with your laptop, it will be a good time to also set up if you don't have Rust set up already on your systems. So now you might be wondering why I did not set up Rust, or why don't I have it set up. Actually, I didn't want to set it up until we needed to do it manually, step by step. It was supposed to be more like, okay, this is how to set up Rust on your systems, right? If you don't have it. But now that we have it on this call, let's just jump into it. So the first thing to set up Rust, let me increase this. If okay. So the first thing to do, right? Because I want to set Rust now locally so that we can test. Yes. Because I want to show you guys how this works. I can show you from here. I can execute this and you see the value, right? But then this is not dynamic enough for me to explain to you guys. See, it's timing out. Maybe it's my network at the end of the day. I don't even understand. But let's just proceed, right? So the wrapping methods, you can opt into wrapping arithmetic on a per operation basis. So like I said, if you use the wrapping method in Rust, when you add 255 and 1 together, what do you get? You get 0, right? Because you have gone past the maximum size of a U8 data type. So you will start again from the minimum value. That's the meaning. So now let's look at the saturating methods now. So this is the wrapping method. This, you already understand this. I've explained it from here. Saturating methods, how it works. And then if you look at the saturating methods too, you can use the saturating method. In which sense? Saturating method simply means that you will return the maximum value or the minimum value. So it simply means that, let's look at the saturating method. Okay. Sir. All right, now let's look at the saturating method example. For the, you've seen the wraparound method, right? The example of the wraparound. Let's look at the saturating method example. Now, the saturating method example, what does that do? Or how does that work? Sorry, just a minute, please. Okay, so the saturating method example, just like the wrapping addition, right? Now, the wrapping addition allows you to be able to return like the minimum value again, to start again from the minimum value. But the saturating example or the saturating method returns just the maximum value for an overflow and returns the minimum value for an underflow. Do you get now? So let's say, for instance, let me give an example here. Let's say we have this. If you have this kind of example, let me copy this example again. Let's say you have something like this, in this case, right? So if I have this, now this basically is going to be, if I get the result of this, right, as a U8 integer type, it's supposed to give me 258, but the value I will get to be 255, right? Why? It's just going to strip off the extra that I have. It's going to assume, if I not assume, it's going to just strip it off. It's not going to count it as important. So that's what I mean by the saturating method. So, but if we are talking about the wraparound method, the wraparound method is going to go back to the minimum value, like we explained here. But for the saturating method, it's going to cut it off. So all these that I'm explaining are very important because when we start looking at code bases, or for instance, now you want to check out the code base on Rust and see what is happening. Of course, it may look like a lot, but these are the little things that you see there, and that makes it look like what is happening. I don't understand exactly. So this is just all of these things. It's not too much, but this is what you have. So that's just it. So in this case now, you can have. So in this case, if you have the saturating method, you can see this. And if you have an overflow, let's look at another flow method in this case, another flow example. So let's say in this case now we have A to be big, like let me call this 20 and this to be 25, right? And if you look at the results, let's say you have your result to be also a U8 integer type, and you do A minus B, right? Which is your like result. Let's say this is A plus B, right? So this is A minus B. A minus B is going to give you 0. But normally it's supposed to be minus 5, right? But it's going to pick what? The minimum value for an underflow. So the minimum value for a U8 integer type is what? Is 0. The maximum value is what? 5. So that's what I mean by it's going to use the minimum and maximum value. I don't know if this makes sense to us. Is it clear? Can I proceed? Okay. I believe it's clear. So you guys are not seeing anything. So I just believe it's clear. All right. So now that we've talked about that, let's look at the next thing. Right. So sorry that I'm not running this. Like I said, this playground is really messing me up this morning. I think it's my network. I don't know if it's my network, but I'll try as much as possible to make sure we can run things before this class ends today. Right. Okay. So now, given that we already have this, excuse me, so we already understand the saturated method or the saturating method, which so in this case, this is how you actually write it out. Let me see if this runs too. This is not running. I just need to write ourselves. Still not working. I really want to explain this. Okay, that's fine. So, all right. So now let's go to the next thing, right? I still have to install the compiler today. Nothing to do about that. So let's go to the next thing, which is conversions as casting. So now let's talk about casting, right? So how does this work? Now, we've repeated over and over again that Rust will not perform implicit type conversions for integers. We've established that today, if not before. And one way it actually happens for explicit conversions. So from your end also, aside from the saturating method or the wraparound method, is to use typecasting. So typecasting is a popular thing that happens in almost all languages. It happens in low-level languages a lot. C++ does it, C does it. All those low-level languages does typecasting a lot. You see that in a lot of code that they have. You also see that in other code like Solidity, where you typecast a variable from, let's say, from a byte 32 to a byte, 32 to a byte 8 or to a byte 4 or to something, depending on what you want to do. Or you cast an address type to something else, right? Or you want to typecast an address to a byte to a value, a smaller value, then you convert to another value. So all of those things simply means that you are changing from one data size, memory size, right? Data memory size to another one. So in this case now, there are ways you can do that. There are multiple methods that Rust provides for you. So let's say in this case now, I want to convert from a U32 type to a U64 type. So one way you can do that, one way you can typecast this, right? One way you can typecast this is, or one way you can convert the value from being a U32 type to a U64 type is to typecast the value. So and you can do that using this syntax as U64. So you're simply saying that even though this is a U32 type, right? This is a U32 type. I want to cast this value into a U64 type. And you can do that using as U64. So you're simply saying B, which is B now, which is this new variable that you want to set the value of A to, right? You want to set A as a U64 type to B. Do you get now? So also you can make the compiler do the infer for you for the memory size by using the underscore keyword. So this underscore keyword just makes the compiler infer the value, the memory size to use. So in this case, if you use the underscore now, you're simply saying that the compiler should use any correct memory size that it feels is the best. So in this case now, you are explicitly stating that C should be U64, right? But you're saying that A should be what now? So A is going to now choose what value to use. That's the compiler itself will choose what value A should be, if it can be. But in this case, it's going to be a 64 type because you've already specified it here. So it makes the job easier for the compiler to choose U64. Do you get now? So that's the limit. So it means that if you specify this here, you can use the underscore. The compiler will just infer the result from here straight up. But if you don't specify the type for this variable, then you can cast it into another variable entirely. Yeah, question. Yeah, go ahead.
All right, sir. Good morning, sir. So I was going to ask, what can be like a possible scenario where you might need to typecast?
Okay, so there are a lot of reasons why you might need to typecast, but one possible one, like you said, is if you have a variable that you know within your code is bound to grow. For instance, say you are storing at the beginning of the code, let's say you are just building for development, right? And you know that okay, this is going to grow. Like when you release to production, it is bound to grow. But remember that when you initialize the variable, you set it as a low data type. But let's say, for instance, now you are now using the result of whatever you are storing to this variable. You want to use it in another data type, in another variable rather. Let's say to add or to multiply. In that case, you know that it is because you don't know the limit to which this original variable can grow. You want to increase the size of this when you are storing it into the new variable. You get now. So it's more like when you are working with dynamic data, and especially it happens a lot in production code because you do not know, especially when it comes to what user use and or things that will grow in size. Let's say memory, like storage, or storing user data. Basically, that's when you tend to use things like this. Or let's say you are counting the number of users on your platform. You know that it can grow indefinitely. You cannot be sure how many it's going to be. Now, you can use a U32 to handle all possible cases. But then, when you now comes to maybe multiplying the number of users by the number of posts, you know that in that case now it's an exponential growth. You cannot really predict how long or how far that value is going to be, or the size of the value. So in that case, let's say in this case now, this is the number of the counter, the user counter, right, that stores the number of users on your platform. Just an example. And this is the variable that stores the number of users multiplied by the number of posts. Now, you know that that's the multiplication value, and that's an exponential result expected. So in that case, now you can store the result of the exponential multiplication by typecasting the value of this to a bigger value. Let's say the number of posts is a bigger value than U32, obviously, because it's going to increase. A user can post 200, 500, 1,000, 1 million posts, right? So it's an exponential geometric growth from user to post. Do you get the scenario now? So in that case now, you cannot really predict the size of that. So you want to make sure that the size of the user count also matches the size of the post. So let's say in this case now, I really wish I can write this. Okay, let me just copy this and write it out for you. Let me write it here. So let's say you have something like this. Let's say this is user counter. Follow trust. In this case, right? And then you want to type this. Let's say this is this is a post like this. So in this case now, let's post counter equals to U64 equal to whatever value. You can say 200, right? Now in this case now you can typecast A as U64 and say B times A. You get it now? So now both of them are the same data type here and here. So both of them become U64 data type. And that means the user post also becomes a U64 data type. And the U64 data type is large, like it's very, very large. So now you are typecasting this value to U64 type so that your multiplication here can be done easily by the compiler, inferred easily by the compiler here. I don't know if that makes sense.
Yes, it does. Thank you. Thank you very much.
All right. So that is one way. So now let's go back to looking at that. So you can use as. As is one way to typecast your variables from one data type to another data type, right? So another way you can do that is by using truncation. Now, truncation is a method that goes similar to the as, right? So, but it's more like in the opposite direction. So in this case now, using the as, one thing to mention that I didn't mention is that using the as, you are going from a lower data type to a bigger data type. So a smaller data type to a bigger data type for the as conversion. So when you say that you are converting using as whatever to a new data type, you are going from a smaller data type, which is in this case like a U32 to a U64, or a U8. In this case, this can be a U8 to a U64. That is valid. But you cannot go from a bigger, so if you want to go from a bigger data type to a smaller data type, you are talking about truncation now, not the as conversion. So you are talking about truncating the value. You get now. So in this case now, this is truncation. So if the number is too big to it, you can convert it, you can reduce it into a smaller data type. Yeah, so that's one way too. So in this case now, the number, let's look at this example. I can't run this, I'm so sorry. Things get more interesting if you go in the opposite direction. A number that's too big to fit into a U8. So let's say this is a U16. I know that a U8 cannot take 256. It's violating the rules of the Rust range, right? Arithmetic values, arithmetic sizes. So now in this case, now this is 256. But B can now be typecasted to a U8, which is supposed to fail, right? But it's not going to fail. Now, because look at this now, because as conversions are infallible, but what is the value of B? When going from a larger data integer type to a smaller one, the Rust compiler will perform a truncation. In that case, it means that what? It will just cut away what is not meant to be there. I remember we talked about using the wraparound method that is going to return it back to the original value. It will start again from the lower value. So now in this case, now the value of B here will be 0. Using that same wraparound method. So if you are truncating a value, right, from a larger data type or a bigger data type to a smaller data type, what is going to happen is truncation. Truncation is going to happen. And what Rust does with that truncation is to start the value by subtracting the original value here. That's the value you get. I want to truncate to the smaller one, right? By subtracting it from the maximum value. If it's an overflow. Now, if you subtract it from the maximum value, that means 256 minus the maximum value is also 256, right? So the value is going to be 0. So that's basically what is happening. So if you want to understand this, let's look at this. To understand what happens, 56 is represented in memory as a sequence of bits, right? So it's a sequence of 2 bits, the first bit and the last bit. So when converting to a U8, the Rust compiler will keep the last bit of a U64 memory representation, which means this. And that is what is here. Now, hence 256 as U8 is equal to 0, right? So that's not ideal in most scenarios, right? In fact, the Rust compiler will actively try to stop you if it sees you casting a literal value which should result in a truncation. I really wish I can do this right now. So you can see it. I wish this is going to work. Oh my goodness. Okay. All right. So fine. Let's proceed. It's not, I don't know, maybe my network is still acting up. But do you get this point? This is basically what happens here. So truncation happens, which in this case is just going to basically subtraction of the actual value from the maximum value. But in this case, because if you want to look at it in terms of bits, it means you are splitting the bit value because you've gone beyond the range, right? And you are truncating to the smaller range. And so that means it is cut away this guy and just pick this. And if he picks this, because all the bits here are 0, the value is going to be 0. But Rust will try to stop you, like you can see here. So it will try to stop you. And that's what I want to show you guys, but sorry, I can't show you right now. So recommendation as a rule of thumb, be quite careful with hash casting. Use it exclusively for going from a smaller type to a larger type. To convert from a larger type to smaller type, rely on the fallible conversion machinery. We will explore that later. Don't worry. There are other ways to convert that are actually much more, should I say, efficient now? Maybe, yes. So that's one of the ways. But we call them the fallible conversion machinery. But you just call them the fallible methods. Basically, they are the fallible methods. So in this case, which are the infallible methods that we've talked about here? The infallible method are the ones that you just work with, like from one memory size to another. So yeah, I think that's basically what I want to talk about for conversions, because it's important for you to understand these conversions too. As much as we talk about other program types, and we talk about the data types too, and how to use them. So we should also talk about the kind of errors you can have. So when you see things like this happening, or you see implementations like this in the code, there are reasons for it. There are reasons why people want to start a value once it gets to 255 and truncate it. People do it. Yeah, it's done. It's done for many reasons. So let's say you want a value to be maximum of 255. That's what you want it to be, for whatever reason you want your value to be. So you want it to be that whenever the value grows beyond 255, return it back to zero and start again. So for many, that can be your logic, right? Your logic depends on what you want to build. So if that is your logic, what you have to do is just typecast the value to a smaller value at this point whenever you get your results. So it's anytime it gets to 255 and goes beyond 255, it will return it back to U8 to zero and starts all over again. So that means the value will never go beyond 255. There are many reasons why you want to do that, but it depends on your logic though, like I said. So that is just to show you guys the type of conversions we can have, overflow and underflow errors, the type of methods that you can use around those kind of errors, and conversions also. Right. So now, any question from this before we go into the more interesting part, which are structs, the juicy part of Rust? Any question, please? Okay, so I assume there are no questions. Okay, so if there are no questions, basically, uh, okay, so no questions, then that means we are good to go. All right, so now, well, for me to be able to talk about struct, right, I really like to run some code. So you guys should spare me like a few minutes to set up. I didn't want to do this for this class. I wanted to do it in the next class so that we can set up Rust from scratch for those that don't have it set up. So I assume that most of you have it. I'm assuming that, but I assume that majority of you don't have it set up. So for currently, I don't have it set up on my laptop, right? Yes, I wanted to do a walkthrough of how to set it up, but because I feel like we need it for this class. So I feel like we need for this class. So I'm going to actually set it up. Right. But now let's just go into struct first of all. So now we've done the chapter 1 and 2, right? So we've implemented the basic calculator, right? We've done a lot of conversions, all of those things. So if you have to do our calculator now, I'm sure we can write something like that. We can implement a basic calculator that does a lot of things. We've written an add function, so that shouldn't be a problem. But now let's look at the third one, which is the ticket. So we are still going to come back to, like I said the other time, we are going to come back to what we've done before, right? Come back to all of these things and come back to them, pick things from them, learn more things from them as we proceed. Because at the end of the day, all of these big things, all of these complex things are just different variations or different additions of the smaller ones. Do you get now? Let's go. Before we go to all the best of Russia is where they happen. Oh my God. Why is this happening this morning? It's too early for this kind of network issues. Hmm. Sorry, hope you guys can still hear me and see my screen, right? Because I feel like the network is misbehaving so much. My screen may go off. So if it goes off, please know that it's network and just bear with me a bit, please. Browser. It's just off. Browser can I use? Make a new window here. Okay. What's here? Doesn't work here. Ticket version 1. Okay. I think just stick to this then. If this fails to work. All right. So I think I'll just create a cross playground. Sorry, excuse me, guys. Just a minute, please. Okay, sorry, let's proceed. Cross playground. Since I think it's that browser that is misbehaving. So I just leave that out. Let me increase my screen here. Okay, so okay, it's not my browser. Just my network is just awful. Sorry about this. Seriously, so awful. Oh my god. Ah, okay, let's just try to install Rust like from scratch now. I wanted to do this next week, but then I'm doing it today. Like I can't wait for this. I have to show what is happening here. Okay, this is showing. All right, let's see if it's going to work now. So modeling a ticket, right? The first chapter should have given you a good grasp over some of Rust primitive types, operators, and basic control flow constructs. Now, in this chapter, we'll go one step further and cover what makes Rust truly unique, the ownership. Now, this is the interesting part of Rust. Now, this is what truly makes Rust unique. And this is one of the reasons, in fact, the major reason why Rust became one of the most sought after language. For the past 4 years now, Rust has been like the best language in the developers ecosystem. And you can see the way it's growing every time. Everybody just wants to use Rust one way or the other. So it's because of this thing called ownership. Now, ownership is not so difficult to understand. It's not something complex as you might have heard about it. It's just a rule just 3 rules, basically. Ownership is just 3 rules that govern what you must do with variables, and that's all. Don't worry, we'll talk about it in detail. Let's just follow along as this is. So just know that it's very simple. Like ownership is very simple. It's not complex at all. If you get a good explanation about it, it is very easy. So now let's see. Ownership makes Rust fairly unique. Yes, ownership is what enables Rust to be both memory safe and performant with no garbage collector. Now, if you're familiar with other programming languages, for any of us that are familiar with it now, most languages use something called the garbage collector. The garbage collector, in this sense, is what handles for interpreters for interpreted languages. What happens is that when you say garbage collection now, whenever you execute your code, there are bound to be garbages. And it happens for every languages. Every language has garbage. And what we mean by garbage is when you execute certain things, some things are not needed. Like for instance, you have unused variables, right? You have unused unused memory spaces. All of those things are garbages because the compiler doesn't need them. So at the point of executing your code, when you run your program, let's say, let me not even go to Rust now. Let's start with a simple programming language. Let's say which one? Let me not say simple. Let me say common. Let's say either Python or JavaScript. Those are like very common. So let's say we expect Python, for instance. When you start with a Python code and then you execute a Python code, no matter what that code is meant to do, right? The fact that you can define a variable and not use that variable, or define it and the value that you pass to that variable is never used, right? Or sometimes you have no choice but to define a variable that you will not use because based on a condition, an if statement, it might never get to execute. Now, in that case, those are garbages. And then every program, every compiler, right, understands that this is supposed to happen. So from the grammar written for that compiler, the grammar that is going to be the set of rules for what the compiler should do with that programming language, it knows what is garbage and what is not garbage. So most programming languages have what they call a garbage collector. Every language you've seen has a garbage collector up to Rust. Rust is like one of the first languages, not the first, I guess. Yes, I know it's the first, but it's one of the most popular languages or recent languages that do not use a garbage collector. There are languages that don't use that before, but they are like old languages. But Rust is one of the newest languages that do not use garbage collectors. So it enforces you to write everything safe so that you don't need a garbage collector. That's just it. So so for garbage collectors, what they do for the interpreters now is that when they see all of those things that you don't make use of, they collect them, like, and then they optimize your code for you, knowing what to remove and what not to remove. You get. So a lot of all codes, all programming languages have it. Java does, Python does, JavaScript, Node, rather, let me not say JavaScript, Node. All of those languages have what we call garbage collectors, and they use it for optimizing your code, right? So all of those languages do, but Rust does not have the garbage collector. So as a running example, we will use a Jira-like ticket, the kind you use to track bugs, features, or tasks in a software project. So we'll take a stab at modeling it in Rust. Now, this is what we want to build now, right? For this iteration, we are going to build we are going to start with building. We can't build everything now, but we'll start by doing that. We'll start with an actual exercise that we can see how to model using struct, how to define custom types, how to create your own custom implementations for your struct, or how to use ownership, memory management, pointers and all of those things. We will see them in this exercise. So it will introduce us to them, and then it will make it easy for us to build on them. But now we'll take a stab at modeling it in Rust. It will be the first iteration. It won't be perfect. Don't expect it to be perfect. Not very idiomatic by the end of the chapter, because we are still learning, right? So it's just going to be, we are going to use the rudiments. We are going to use crude implementations. It's not going to be standard. It's not going to be professional. We will still make it professional eventually. We will iterate over the program. But for now, because we are just introducing ourselves to the complex data types, we'll just go deep into it, just start with it, and then we'll pick up along the way. Now, it will be enough of a challenge though, right? It will be enough of a challenge. To move forward, you have to pick up several new Rust concepts, such as struct. One of the Rust ways to define custom types, ownership, references, and borrowing. Now, ownership and borrowing are two major features in Rust. They are very interesting. They are very important to know. If you don't know these two things, you obviously don't understand Rust yet. That's the truth. So once you understand these two concepts, you can call yourself a Rust developer like 40%, because you understand, you can read any Rust code and understand what is happening. That's the idea. So that's the first thing. So the next thing you see is that you see this memory management, stack, heap, pointers, data layout, structures, and all of those things too. Right. So you still learn all of those things in this. Then we have modules and visibility. Now, the idea of having modules and visibility is that we can't have modules now. We can't create modules on the Rust playground, right? So that's why I was planning this for next week before the installation. So, but we still have to do that today. So having structs, we have to learn about structs, ownership, references, borrowing, memory management, the stack, the heap, pointers, data layout, the structures. Most importantly, we should know this very much. We'll talk about stack and heap. We'll talk about the differences between them, how they work, what they do, and the reason why they exist. And then the data layout, basically, we understand that from pointers already. Then the structures. So we'll talk about the structures. The structures, we'll talk about the modules and visibility. So modules basically is how you create your code in modules, how you modularize your code. That's why they call it modules. So, and visibility types. Visibility types, for those that are familiar with, I know some solicited devs are here, right? Visibility types basically means the accessibility or the visibility you give to your code, whether your classes or your functions or any code within your programming block, right, of code, whatever. So the visibility that you define there, you can also define visibility in Rust, just like you can do in almost, in fact, in every low-level languages like C++, like C, like what's the name again, Zig and the likes, V and all of those languages. Now, all of those languages allow you to specify visibility. You can define visibility for your code, and that is what we are talking about here. Right. So basically, you are defining visibility in this case. And you will see how to do that in Rust when we talk about modules, because you can use modules to define visibility. Then we'll talk about strings also, right? Of course, we've mentioned string before. I've shown you guys what string is and how you can initialize, but I just talked about it. We never went deep into it because, like I said at that time, a string is one of the most complex data type in any language. You make it simple for you, but it is the most complex data type in any programming language. It's the most complex. So let's jump into it and let's start. So the first thing to do is, thank you, Jesus. Let's start with structs, right? So we start with structs, and we need to keep track of. So this is what we need to keep track of. We need to keep track of 3 pieces of information for tickets, because remember we are building a ticketing platform, kind of like Jira, right? That's what we said here. We are building something like Jira for tickets, for like tickets you have to do. So use it to track bugs or features or tasks in a software project. So we are simply building something like Jira, but very, very, very basic. So we want to use it to track bugs, features, or tasks. But in this case, our own struct is going to be very simple. What we are going to be targeting in this case is just what is the ticket all about. So we are going to give it a title. We are going to describe the ticket, and then we give it a status. Now, looking at it from here already gives you an idea that, so is this thing big enough? Can you guys see it clearly from your end? If you can, please let me know. Is it big enough like this? I don't know if you are checking from your phones. Okay. All right. So if it's not, please just let me know so I can zoom in. And so now for the structs, right? Basically, when we have this, when we have let me collapse this bit and increase this. I think that's better. Okay. Now we need to keep 3 things, 3 informations about the struct. Now these are you model your struct, right? We could talk about data modeling, because when you write your program, or in most languages that use struct, like C, right? Like C++, like Solidity, these languages use struct a lot. They have struct. They have something called struct. Now, what struct is just a way to group different data types. Do you get it now? So in this case, when you have struct, you are simply creating a model of a model or a group of different data types, of simple data types or of other data types. Let me use that one, not simple now, other data types. So when we create a struct in Rust, you are creating a model that you want to use within your program, right? To group different data together so that you can access them as one entity. That is what your struct is. So, like I said, in C, in C++, in which other language, Solidity, most every low-level language that we have, it is basically you have the struct as a model of your program, of your logic, right? So in this case now, we're also creating a model of what we want to create for our ticket. So now, since we know that our ticket needs 3 things, what does it need? It needs the title, it needs the description, and what else? It needs a status. Now, a status in this case is whether it is completed, ongoing, or not started. Those can be status because we are keeping track of task, right? Software task. Those are things that can happen. If you're familiar with Jira, those are the things you see on Jira, and you can define custom status too. Now, in this case, now let's see. Those are the model, right? That's the data we need to model. So now, we can start by using a string to represent them. String is the type defined in Rust standard library to represent UTF encoded text. What do you mean by UTF encoded text? Unicode, right? So don't worry, let's not go there. When we get to string, I think, like I said, string is the most complex data type in every programming language. But let's not go there yet. So basically, string data type in Rust is an abstraction over creating Unicode encoded data types or text. Basically, that's what they mean. So how do we combine these 3 pieces of information into a single entity? Just like I was explaining the other time, you combine information, you group them into a single entity so that you can use them and define logic and implement even custom methods for them. So that's what a struct is in any language. So you need to define what your struct is going to be, what information you want to add together. That's the first thing. So once you have a group of information that should work as one entity, the best thing to do at that point is to create a struct for them. In other programming languages, like high-level languages like Python, like JavaScript, like Java, like Go, and all of those languages, what you want to do in this case now is to define a class for them, right? Most of them, like Rust now, Rust doesn't have a class, just like C doesn't have a class, right? So in this case now, instead of defining a struct, for those high-level languages, when you define a class, in those cases now. In Rust, you define a struct. So I'm just making reference to all these languages so that if you're familiar with any of them, when you use a class in them, you can think of, okay, that means this should be a struct in Rust. So a struct basically is like a class in other languages. Don't worry, that's just what it is. And if you're familiar with C++, you'll be familiar with that because a struct and a class, they are the same thing, just visibility difference. Let's leave that now. So defining a struct, how do you define a struct? A struct defines a new Rust type, right? That's what it is. So in this case, now, we've talked about the basic data type. When we mentioned types of data, I don't know if you, okay, here, basic data type. We talked about integer, string, boolean, character. And then for the complex data type, okay, which I did not write, I removed it. For the complex data type, right, we have other types like structs, like arrays, right? Those are other complex data types which you have. And then struct is one of the ways you can define a new type in Rust. So it simply means that just like you have integers, right? You can define your own custom type. Now, and based on what I've explained about struct that use it to group information together that function as a single entity. So that means you can create it as a new type. So when we talk about struct, you are simply creating a type in Rust. So that means the same way you can use your uint 8 like this, like this, right? Or uint 16. I can define a data type, call name, or person, or user, and call it my type. My will be the type, and then I'll create it as a struct in this case. So, but let's not go here first. This is just hints of what we are going to do. So when a struct defines a new Rust type, in this case, now when you have a struct like this called ticket, remember we are building a ticket clone, a Jira clone of a Jira ticket clone, right? So we are creating that. So remember we said three things are grouped together: the title, the description, and the status. So what we do in this case is we combine them into the struct so that we know that this ticket now means you have these things. We are grouping them into an entity, and the entity we are grouping them in is called the ticket. And ticket already, the moment we create a struct like this for it, it becomes what? A type. And you see that we still have that scope that I always mentioned here, and the logic and the body of the struct. So the item that you have inside here, all these things you have here, are members of the struct, right? They are the members of that struct. They are what makes up that struct. So now this is already a type. So in this case now, if I have the struct defined like this, I can use it here. I can say something like ticket, right? Or yeah, single ticket or current ticket like this. I can define it as a ticket type like this, and then I use it like this. So you can see that I'm using it just like I'm using U8 before. But in this case now, I'm using it as a type, and I'm the one that create it. So that means I can create something like struct ticket. And in this ticket now, I'll just have something called, what's the first thing we have? Title, right? Title. We should have the string, comma. We have the description. We have the string, comma. Then we have the status. For now, yeah, string, capital S. Right? That's what we have for them. And so that means from here now, I've created a type. And this type here, I can use it here as a type. It's just that simple to create your own custom type. Your custom type can have logic the same way we have U8 that has a maximum and lower, this and that. It's just implementations. That's struct. Or we'll talk about that more. Now, a struct is quite similar to what you call a class or an object in other programming language. Exactly, like I've said, right? You can call it a class in other languages like Java, like Python. They are just so yeah, so that's basically what we have, right? So now let's define fields. Now the new type is built by combining other type called as fields. So now means whatever we have inside of the struct like this. Now these are fields, right? All of this inside the struct, they are fields. Do you get it now? So now the new type is built by combining other types as fields. So each field must have a name and a type separated by a colon. Do you get it now? A name and a type separated by a colon. So if there are multiple fields, they are separated by a comma. right? So in this case now, a name, a colon, the type. But because there are multiple types, you separate them with what? A colon. Now, fields don't have the same data type, right? As you can see in the configuration structs below. So let's say you have a configuration struct too. You can see this under struct now for configuration. You get it. So if I want to create another struct, now say I want to create a struct for a person, right? I can call this struct person. And this struct person is going to have a name. It's going to be a string. It's going to be, let's say it has an age. It's going to be a U8, right? The person can, we assume that you can, the person that we are storing our struct should be more than 255 years of age, right? Then let's say the location is also string. Let's say your bio is string. It's also string in this case. Then we have your address. Location should serve as your address. We say your country. Your country can be an unknown, but you're not doing that. Let's leave it as a string. We've not talked about Then we can have, we can also have a lot of all these things here. Like, so this is a struct. Now, if I use this now, I can do this as person. And I can also call it my name as my struct. You get, so it's a custom type. So it's my custom struct. Whatever I call it is me that want to use it. So I know what I'm using it for. Do you get now? So that's what we call a struct, and that's how we define it. Now, how do we instantiate this? You can create an instance of a struct by specifying the values for each field. What do you mean? We can create an instance of a struct by specifying the values for each field. Right? So now, let's say we want to create a struct. Remember when I said you can create this like this? Do you guess now? So if I want to create a struct like this from this ticket, how do I do it? I write the struct name and I open a bracket, a curly bracket like this, and then I pass the value into it. Get now. Now let's look at the example. I want to write the title. I'll start with my title, that which is the first thing here. I'll start with that. The value is what? Is of type what? String, right? So I'm going to write a string. I can just say closed. Those are three. Now let's see. So this is about we created a struct called tickets for our Jira-like app that I want to build or program that I want to build. And we've created a new ticket. So I can call this new ticket now. This is the first ticket. So if I'm creating a ticket now, this is what I will have. So in this new ticket, if I create it, I'm going to have build a new ticket system as the title. Description is a Kanban board and the status is open. And I've successfully created a new ticket using this struct. Right? If you're familiar with any other language that use struct, it's pretty much the same thing. In Solidity, for instance, it's just different in the sense that you wrap it around this type of brackets too. Right? In C++, it's similar to this. You don't need to wrap it around anything, basically, aside from doing something like this. So in C also, rather. So do you understand? So this is basically what we have. So you have created a ticket like this, just by specifying the values for each of the item, each of the fields in the struct. So that's that. Now, once you have done this, how do you now access the values or the fields in the struct? Now, you can access the fields of a struct using the dot operator. It's very simple. Now, let's see how that works. Now, you can see that Rust is quite simple, right? Like, this is the bulk of what you'll be doing most times: creating struct, implementing struct. But let's not jump too much yet. Let's not jump too much. Let's just take it little by little. It's quite interesting when you look at it this way. So now at this point now, you can see we have we've created our struct, right? We've created an instance of the struct. We started with the struct and we've created it. And then let's talk about accessing fields. Right? How do you access the field? So let's say, for instance, we have this ticket which we've created. Let's say I've created this new ticket. Let me know. Okay, this one should have this, right? And I can put my name and all of this, but let me comment this out. And then let's say we created this ticket. How do I get the value of the title of the new ticket created? Now, how do I do that? What I need to do is, since this ticket I created is saved into where? Into new ticket, right? What do? I do this dot what? The values, the field rather. The field here, let's say I want to get the title, right? Based on what I said here, I'll just call it title because title is the field I have here. And once I define title, title is going to give me what? It's going to give me build a ticket system. That's what it's going to return for me. So the key to get or when we get there, we still have a long way to go. But if you can keep it in mind, it will make a lot of sense because I'll make reference to it then. So you can see they refer to it as an operator. So if I call it an operator, understand why I'm calling it an operator. But even though I'm not explaining why yet, but we'll talk about why later. But just know that it's an operator. But for now, I might not call it an operator too, just to avoid confusion. So you can access the field using the dots. I'll just call it notation or operator once in a while. So now let's talk about the methods now. How do you create a method? You remember that when you talk about classes in other languages, high-level languages like Java, like Python, like JavaScript. I keep making reference to them because they are very common. Yeah, or yeah, even other languages, any language you can think of that is high level at this point, no matter the language. You know that you can create something called methods on them, right? And because struct is like a class, it's basically a class, but without the class, right? That's what it is, without the name class. You can create methods on the classes. Remember that when you create a class, let me give you an example. Let's say I create this now. I don't know if I have this installed. Okay, I do not have it installed. Wow, I thought I did. Sorry. Okay. Now, given that, let me exit this. I'm just trying to show you guys something before like proceed. I don't know if this is clear enough. No, it's not. Let me zoom in. Okay, so let me try to prove what I'm going to show here. So let's say oh, not there. It would have been easy for me to use it to explain. How come I don't have it on this? Okay, fine. So now let's say I have this, right? I can define a class like this. Sorry. Okay, so I can have a class like this, right? Call it a name, Python. And then I can define a method. I can define the method like this. So I can say pass. I can just do this. It works. And then I can define this. Okay, let me just define set, right? As a method. On this is not like the best approach, but then it works too. So in this case, you can say return name. So let's assume I've defined name at this point, okay, because I can't move up, right? What it basically means, I can say self dot name supposed to be somewhere, and I'll define that as let's say I define that as my name. Now, what I'm trying to drive at is that what's the complaint about? Invalid syntax, whatever. What I'm trying to drive out is that I can have this name like this dot get dot set name like this, and it's perfectly valid because this set name now is a method on this class, right? It's a method on that class. So obviously I can't return this directly. Like I'm supposed to set it then, like because there's nothing called self.name anywhere. But you get the idea. But this is a method here. Called set name is a method. And the reason why we call it this is because we define it in the class, right? So now looking at that, using that understanding now, we can also define methods for our struct. Now, how we do it in Rust is a bit different from how you see it in other languages. Other languages, you see it just like I did here. You can see that it is created inside of it. If, for instance, I want to use a node now version, right, to create something like that, I'll create a class in JavaScript and call it person, for instance, right? So let's say I create a class called, sorry, I create a class called person like this in JavaScript. I can define a person method, right? It's possible I can use a function, or I can just call get name like this. And inside the get name, I'll just, what are you doing? Node. Oh, shush. Inside the person class name, yeah, that's quite everything I wanted to do. Sorry, you get the idea, right? It's still the same thing I wanted to do. So I have get name like this, and then I can define the set name. So in this place, I can just return name, assuming that I've defined my name already at like constructor time in this case. So I can return the name like this, and I can define the value and define the class. And so when I define person like this, you can see it's a class, and person has options, right? Get name in this case. So if I define this now, okay, new, I'm going to use a new keyword. Sorry. If I define this, you can see that it's already giving me this instance, kind of like what you have in the Rust. And you see why I'm pointing this out now. So you can have something like this also, kind of this kind of instances, right? So you can have this, and you can see that the person is returning something like this ticket or this type that we have here as a struct. Do you get now? So what I want to do is I want to get the name. You can see that it's returning a name for me. Name is not defined, but I'm able to reference the name. So if I type new person again, right, dot, and I make reference to this, it's supposed to give me the type. But now let me just save this to this. So mp dot, supposed to give me the value. Sorry. So it's supposed to give me the value of get name. You can see it's a function. But in this case, it's not actually a function, it's a method because it's inside a class. And you can see that it's making reference to that method, but because there's nothing called name, it's going to fail. It's obvious. So now this is what we refer to as a method. Now, first of all, you can see I gave us this person like this, like a struct in Rust. Do you get that? So that is very important. So it simply means that when you create this also, you can see that it's just like a struct. So even though it's a class, right? And then you have methods that you can define on it. The same way the method, right? You can do the same thing in Rust, but in a different syntax. Now let's look at how you do it in Rust now. So in Rust, what we do is that we create an implementation, right? Now we call them, now when you create your class, you are creating an object. When you create your struct, you are creating an object. But for every object you create, you want to have behaviors for those objects, meaning that you want to create behavior for them. You want them to have their own behaviors on how they should work, how they should operate. That's what you want to have. Now, in this case, now creating behaviors now for our ticket struct. How do we do it? We need to use something called an implementation. You must have heard of that word before, implementation in Rust, right? But that's what we use in Rust to define methods for our struct. Now, how do we define an implementation? So say that, let me use this type ticket now that I've created here as an example. Let me remove this, right? So say I have this ticket that I've created here. I want to create an implementation for ticket. What is the implementation going to be? It's just the behavior. Just the same way I have this and I want to use get name on it, right? Think of the possible implementation I can have for my ticket. one example I can have for my ticket is I can have an implementation that checks if the ticket is open, right? I can have an implementation to check how many tickets are open, right? So now, what does that mean? So I can have method. Let's say I want to define it like a JavaScript class. Now, for instance, just bear with me. It's going to be a ticket like this, and then it's going to be open ticket count like this, something like this. Now, in this case, now the open ticket count, I'll have my constructor here like this, right? I will define something inside my constructor, probably this dot ticket equal to, I don't know, I'll just count something. But that's just an example, right? So in this case now, in the open ticket now, I want to count, get the number of tickets open, of open tickets, right? Now I can have another behavior that says get open tickets. Now this one just the list open tickets list. This is just the list of them, but this is the count of them. This how do I implementation? Right, the implement keyword is a keyword in Rust. IMPL. Implement keyword is a keyword in Rust. The implement word is a keyword. Then when you type the implement like this, what are you trying to implement? What struct are you trying to implement is what will come next. In this case, I want to implement the ticket. The implement simply means I want to create methods for a struct, right? I want to create methods for a struct. Now, what struct am I creating methods for? Right? So that means I'll move this now. I'll move it probably closer to my struct because I'm implementing my struct, this struct. So now what do I want to have inside? I want to have a function inside that checks if is open like this. And if it's open, what should I have? Now let's see. I want to check if it is open. Now you see that it takes self, right? It takes in self. Now, just like a JavaScript, self is mainly used in Python, right? So let's go back to the Python example I wrote. Oh, I didn't pass self to this. Yes. But in the normal sense, what will have happened here if I was writing it? Will have been a class name like this and set name. And the first parameter will be a self and let's send name like this. Right. So, but before that can happen, it's going to be return name or it's going to be self dot name equal to name. Right. And then that's just it. So this self now you can see is similar to what we have also in Rust. So if you're familiar with any other language, jumping to Rust is just finding a way those language works in your own previous language that you're using. Sorry guys, can you- Okay, so let me share my screen
guys hear
back.
me?
Wow.
My network is
It's really shitty today. Sorry, can you guys see my screen now? Network is really messy. So sorry about that. Extremely messy. Oh my god. Okay, yes, we're back. So all right. So now I'm sharing my screen again, right? And let's proceed from where we stopped. So I was talking about the implementation, right? Before we went up. And I said you defined after defining your implementation for the struct by passing the name of the struct, you define the method. Now, the method in this case is just a function, but because it is used in a struct or a class, it becomes a method. But at the end of the day, just a function, right? And then what that means is I define my function. What does my function do in this case? I want to return a function to check if the current ticket I'm going to be using this method on, in this implementation on, is open. Meaning that I want to check if self dot what dot status, that's what I want to use, is equal to what open, and it's going to return true or false. We want to return passing what, passing the calling the bracket, sorry, the semicolon sign, right? I'm going to pass in the semicolon. Why? Because we are returning this. It's just like you saying return this, right? But implicit return. We are just doing implicit return here, and we are returning this. That's the meaning. So that is just clear, right? That's everything. So in this case now, I've defined my first Rust method. So you guys now, if you are writing this, if you're following me, but don't write it now, right? Please just try to understand what I'm explaining first. If you follow this, probably when you watch the video, I'll release that, and then you go over it again, you see, you can then begin to try all of these things, and then you see it work from your side. So in this case now, I'm simply saying that I want a method on the ticket struct such that if I have something like this, new tickets, I can now have something like this now, new ticket dot, right? I will now have something like new ticket dot is open here. Do you get now? So now, because this is a method on this struct ticket, this is a method, is open is a method on ticket. What it means now is that I can use it just the same way I was calling type, right? I can now have dot is open like this, and to tell me if it is open or not. That means if it has a status of open, that's the meaning. So does that make sense? So that basically means you've created your method, your first method, right? And what's the syntax to creating your method? Like I said, you create an implementation, right? You create an implementation, and just like you have here, you're going to have this. So inside of this now, you are going to have the body of the methods, rather. You can call them the methods in this case. So which is what we have here. So you can call them the methods. The method in this case now are the functions. The function, just like you have normally, it's function name, right? So sorry about that. So it's going to be the function name, right? In this case, so this function is the function name. use self as their first parameter. Self is a keyword and represent the instance of the struct the method is being called on. Now, self, if a method takes self, excuse me, as its first parameter, it can be called using the method call syntax, which is what I explained at that time. So now we can have is open on this ticket, right, that we created because we've implemented this method on struct. So that's what it is explaining to us too, right? So you can see this is the same calling syntax you used to perform saturating arithmetic operations on U32 values in the previous chapter. So what does this tell you now? So this simply tells us that that is saturated or is saturating or wrap around method that we saw. Let me show you what we're talking about now. This saturating arithmetic that we saw implemented on what type. So that means the integer type is a custom type. Do you get it now? So that means you can create your custom type and implement methods on it. And then I said it last week that we are going to write our own method. We are going to implement method over the standard library. And now you can see that we've implemented our first method by creating a method over the struct. Right? So you can see that it's the same syntax. So that means what is happening with wrapping add or saturating add here is that Rust itself in the standard library created the method over the integer data type. And that is similar to what we've just done in this struct now. Also, we've implemented a method, right? We've implemented a method over our own custom type. I don't know if this makes sense to anybody. Does it make sense? Are we clear on this, please? Any questions? Who is lost? Okay, cool. So I think we are okay, we are good to go. All right, so now giving this, I'll give you the understanding we have from this now, right? We pretty much understand how to create our structs and methods. Now, this is a good place to stop the class for today because at least we've done this, but let's just try to finish this section before going to the next one, the next class. So now, that means we already understand. So the same calling syntax. So that means we can create our own custom methods on any struct. In fact, we can extend the integer data type and create our own custom methods on it, which we are going to do eventually. So now let's talk about the static methods. Now, if a method doesn't take self as its first parameter, it is a static method. Now, this thing is also common. It's common in almost every language. It's common in Python. You see it in every language. In Python, in JavaScript, in Java, there's something called the static method. In C++, everywhere, something called static method. If you go and check it now, you would probably see it now. And what that means is that you have a method that does not take self. That means it does not take an instance of the class to implement itself or to run or to execute. But all of this that takes in self is very, very attached. It is very attached to the struct, meaning that you cannot execute this function without the struct. But in this case, for static methods can be executed without taking in the instance of the struct. So that means even though they are defined within they're implemented for that struct, they are not too embedded within the struct. That means they are not too tightly related. Not related is not the word. They can be called right without instantiating the struct. Let's see an example. As the word I'm looking for. So if a method does not take self as its first parameter, it is called a static method. And let's see this configuration example. So we have a struct like this. You already understand how this works. But in this case, there's a Boolean and integer type. Now we define an implementation for this configuration. Now this self simply means an instance of this. So if we were to call the open, in this case, we need to use a struct to be able to call is open. But for static methods that don't take in and things will work. You can work for just the struct name. Network. I'm so sorry. Network is terrible today. Don't need to face. In this case, for configuration here, you have this defined. So in this case, now let's say we have, okay, fine. Let's look at it this way. Let's define a default implementation for ticket 2. You can define a default implementation for ticket. The implementation here will just be a ticket. A ticket, like a default value for a ticket. So let me say this defines define a default value or default values for a ticket. That's the meaning, right? So in this case, now let's just say a ticket takes what title. You can say title is this empty, description empty, and status pending. So this is a default value, right, for our ticket. Now you can see it's the same thing that is happening here. So, but in this case, we are returning. Sorry, I forgot to add the return. We are returning the ticket type. You get it now. So we are returning the ticket type. So if you look at this now, that means anytime you want to call default here, you can call default by just passing ticket default like this without instantiating anything. The reason is because you want to be this works whether you have a ticket created or not. And you are not attaching it to an instance of called tickets for every kind of ticket. That means yes, that and then the method name. And so that way we can just do something like this for those that have the self parameter passed to them. You have something like this. Those parameters something like this, you understand what it is. It's simply because both of them are coming from the same place, as you can see, but then the way you make reference to them are different. You get now? So that's that. Like that is just it. So now, but also you can still call the, how do I put it now? You can still call this, right? This open here using another method. You can do something like this. Ticket is open like this, right? And this is open now. We take in new ticket. Still works, right? So it just depends. Whenever you see something like this, if it takes in an instance of a struct, you can still define like that's basically what they are making reference to here. So equivalence, you can use the function call syntax even for methods that take self. And this is what we call the function call syntax. This is what we call the method call syntax. This is the method call syntax. So in this case, this is the method call syntax. This is the method call syntax. This is the function method call syntax. Like that's just it. Do you get? So that's basically what you need to know about this whole thing. So whenever you say a function, it's this kind of syntax in Rust, right? You already understand what it is. The first thing you check is it a function call syntax? Yes, it's a function call syntax. But is it a static method? Is this method a static method? How do you know if it's a static method? By the value that is passed into it as the first parameter. If the first parameter passed in is an instance of the struct, then it is not a static method. But if the instance passed is what? an instance of a struct, then it is clearly not a static method. But if it doesn't take in an instance of a struct, then it is a what static method. So the difference between them is that static methods don't take in self. The methods, not static methods now, the normal methods now taking what self. You get now. So that's basically the difference. So when you see those things in Rust, you already understand that, oh, this is what this is. It's very easy. So looking at this anywhere now should give you that clear picture that, okay, this is a struct, this is a method, this is a static method, this is not a static method. You already understand it. Now, the function call syntax makes it quite clear that the ticket is being used as self, the first parameter of the method, but it's definitely more verbose. Prefer the method call syntax when possible, right? So that's it. So that means when you are working with methods that takes in self, like the normal methods now, you should actually use this. This is easier for anybody to see and read because this can be confusing. Because default can also take in arguments, or you don't want to be tracing if this is an instance. So prefer to use this when you are working with method call syntaxes and use this for static methods. That's the easiest way to understand it. So those are things to do. So whenever you see them say things like prefer to do this, it's because it's a convention. Nobody is forcing you to do it. But when you do it, it makes you stand as, oh, this guy knows what he's doing. And I feel like this is a very good place to stop today's class. We've done a lot of things, even though we did not execute any code today. I'm so sorry for that, but we're able to execute other language code just to buttress my point, right? Because my network today is very, very definitely very shitty. I'm sorry for that, but you guys understand it. So I've tried to make it as clear as possible. But in our next class, definitely we are going to install Rust. Like I'm going to show you guys how to do it. I know you guys might have done it, but still, I'll still do that on the call just to show in case you have errors installing Rust, probably for Windows, for Mac, or for Linux, whatever operating system. So we'll try to clear that, we'll try to fix it, we'll try to resolve any issues we have so that we can start writing our code offline. So we can test all of these things we built, like we use Cargo to run them, Cargo to build them, and see the result from our terminal locally. So we don't have to deal with these online issues too. But basically, that's the idea, right? And also, because we are going into writing actual code now, right? We need to do that offline. I want us to do it because when we get to modules, we'll soon get to modules. By next class, next week, we are definitely going to modules. So when we are going to modules now, we need to define a folder structure that makes sense for building complex or production ready code. Do you get now? So that's the idea. So next week we are going into the as planned. We are going to install Rust, show you guys how to do it, start with Rust installation, do everything I need to do from scratch, and everything works, and then we are done with the host. Once we are done with the host setup, then we go into the class properly, try creating whatever we need to prepare for that day, right? So but I feel like this is enough. I believe this is enough information for today. So like if you understand Rust code, build it, read it, and begin to try your own hands on other things, other code, right? This is just perfect. This is definitely interesting to see. So that's just it. So once again, I'm sorry for the network that's been very, very terrible. I know the network has been terrible. And I thought I had good network, but I just realized today that it's not good at all. Once it's ready and I process it, I'll drop it on Twitter so you guys can see it. But if you want to also get notified whenever I just upload it, let me drop the link to the YouTube channel. You guys can go to. YouTube channel is this. Let me show it on screen. Just a minute. Just a minute. Where is the YouTube channel? Okay, it's this one. So let me just copy the channel, so you guys can always pick it from there. So you can get notified whenever it comes, right? So you don't need to always like fetch it. So the Ross class is out there. You can access all of them. Sorry for my today, really terrible. So you can start with this, or just get the link to the. Let me copy the link and send to the group. So you guys can just check it from your network is just off. So once you go to this YouTube channel or search for I'm a Programmer 01, this is the channel handle. So what you do is just, if you want to get notified, just click the bell icon there. So whenever I release the video and I upload it, you guys can see it automatically. You can just go and watch from there. I don't know, waiting for me to give the notification or the information on Twitter, right, or LinkedIn, whichever. So just go to the YouTube channel to redirect you to the yeah, direct you here. You can see all the videos are available. And there are Rust classes too. So React classes, if you're interested, you can pick it up and also just learn. So it's basically for just programming stuff, programming exercises, live classes. So you can see questions from other guys and use. So that's that. So yeah, that's another way. And also, what else? Yeah, I'll drop it on Twitter. So like I said, just try to practice these things so you forget. The essence of the video recording is so that you can always go back to it. And that's why I'm giving you the YouTube channel, so that in case you can't finish it at once, you don't lose the link. You already know where to go and get it from. So you can go back and say, okay, I will just watch it again. But please and please don't be complacent because of that as well. Try to, as much as possible, go through what we've done today. It won't take you long because you're just trying the exercises. Go through the video, pick the exercise. You can try it on the playground, right? But I'm sure the network from your side should be better than what I have currently. So I don't know, the network is just bad today. And so if once you've done that, right, everything should just work. The structs you've created, you should see the structs, you see the instances of the struct, you should be able to try it out and see the results so that it can stick. Right? That's the important thing, it can stick. So please and please, as much as possible, try to go through everything we've done today, process it, go to the, if you have to make reference to the videos again, please, you can go there, make reference to the videos, right? All the videos you want. If you are, if you like, there's a playlist. I created a playlist for it so that it's easy to make reference to. The playlist is this for Rust, this is for React, not Rust, right? So this is for the Rust playlist. So you can check it and you can see it. So please and please just try to go through the whole thing again. Thank you very, very much. So yeah, so that will be all for today's class, guys. Thank you so much for joining the class once again. So happy you guys have learned something today. And please, like I said, try to go through everything we've done. So that's my advice. I'll keep hammering on that because it's important for you guys to do. So yeah, that would be all. So thank you so much once again. So see you guys next week. Enjoy the rest of your week. And please, any question you have, if you have a question or something that you feel like I need to do, you can either drop it as a comment on the YouTube page, like on the YouTube videos, or I said I wanted to create like a platform for us so that we can do that. But then I don't want to create a platform that will not actually help you to do anything. So until I'm available to do that, so that I can actually answer your questions well, I don't want to just put you on a platform that doesn't help you. You get now. So, but that is in the works. I'm working on it so that any question you have, or if you feel like you need more, whether you want to ask personal questions, that will be able to do that. You'll be able to reach me on that very easily. So that's what I'm working towards, and hopefully, for the end of this month, I should get that out. Excuse me. So that's just it. So yeah, thank you so much once again, everybody, for the class. Enjoy the rest of your week. Yes, and have a lovely day also. Bye, guys.
Thank you. Bye.
Yeah, Judith, thank you.